Hi, Assalamualaikum and a very good morning. So today we're going to do the last chapter of semester 2, which is chapter 13, Polymers. So in this video, we're going to look into the explanation of the terms of monomer, polymers, homopolymer, copolymer, straight-chain polymer, and the cross-linked polymer. Next, we're going to look into the example of natural polymer, and also we have to explain the preparation of the synthetic polymer through the condensation polymerization as well as by using the addition polymerization. Last but not least, we're going to write the use of the synthetic polymers. So without any further ado, let us start. So for monomer, monomer are basically the basic molecular unit where it's going to be repeated in order to build up a polymer. So monomer will undergo the process of polymerization where it's going to be repeated in order to form polymer. So poly refer kepada banyak, mono refer to one. Okay, so polymerization is basically the process that combines monomers, a lot of monomers, in order to form a polymer. So polymer is basically a macromolecule that is large and made up of many repeating subunits. So as mentioned, monomer can be repeated for many times in order to produce a polymer. So in this case, our N here need to be greater than 30. Okay, jadi bilangan monomer yang perlu melebihi 30 in order to transform the monomer into polymer. Example, let's say if we have our ethene here. Okay, so this is an ethene, and when it undergo polymerization, what we're going to produce is polyethene. Okay, so it's supposed to be longer than this chain. However, I just take a few snapshots of what is important. So basically a polymer should be longer than this, and it can continue up to thousands or 10,000s chain. Okay, so this is how you write a polymer because it is bonded together, and then you can also write it in terms of the repeating unit. So you can see that here and here is the same as here and here, and the same here as here. So what you're going to say is that the CH2 and the CH2 part, which is coming from the monomer, going to be repeated by n time. So if your monomer if you're having 100 mole of the ethene, so the number of the monomers that you're going to have is 100. Okay, so it depends on the amount of monomer that you have. Okay, so it helps you to simplify the stuff, or else you need to write it until 100 times, which is not useful. So usually we're going to write the polymer in terms of this form or using the repeating unit and just label the n by the amounts of the monomer that we have. Okay, so that is monomer. This is the polymer. And now for the repeating unit, it's basically the same as the polymer but without the letter n. Okay, so unit yang berulang hanyalah CH2 dan CH2. Okay, and this bond here refers to the connection to the next repeating unit. Okay, CH2, CH2, dia akan bergabung dengan repeating unit yang lain. So, this part here is also important. Same goes to the polymer. Okay, so in order to understand more about polymer, we're going to look at it in terms of the structure, properties, and also the type. So properties can also be known as its composition. Okay, and for the structure of the polymer, it can be divided into two, which is a straight chain or linear polymer or the cross-linked polymer. For the composition, it can be explained using the homopolymer or the copolymer. For the types of polymer, we have two, which is the natural polymer and the synthetic polymer, which is the man-made, buatan manusia. Okay, and for now, let us look into the different structure of polymer first. So, for the structure of polymer, it can divide into two, which is the straight chain polymer and the cross-linked polymer. So, the straight chain polymer is basically consisting of monomer that are linked together in a straight long chain. Okay, so it's going to be looking something like this, and the example of the polymer that existing in this form is the polyethylene. Okay, macam plastik yang nipis untuk membeli barang tu. Okay, so basically they are soft and they can be reformed when heated and also recyclable. Okay, so dia adalah sangat-sangat nipis dan juga mudah dikoyakkan. Meanwhile, for the crossing polymer, it basically contains branches that connect linear polymer chain together. So, the example for this polymer are basically vulcanized rubber. Okay, so the natural rubber which is an example of the polyisoprene, can be vulcanized using sulfur atom. Okay, so the polyisoprene, which is a linear chain, can be interconnected with one another of the straight chain using a sulfur. So this is going to produce a cross-linked polymer which is appear to be harder and more rigid as well as more elastic. Okay, and here is the minor cross-linked polymer. Okay, so cross-linknya hanya sedikit saja, but this one is a massive cross-linked polymer where it is interconnected in a much more complex way. So it is much harder in comparison to the straight chain polymer. Okay, now we're going to look into the properties. So the polymer can be divided into two, which is the homopolymer and the copolymer. So the homopolymer is basically synthesized from the same type of the monomer. Let's say your monomer is all made up of the same type of monomer, which is A, and these are the examples of the homopolymer. So everything is made up of the CH2, 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 and so on. Meanwhile, for copolymer, it comes from the word cooperation. So maksudnya, different monomers bekerjasama in order to make up another type of the polymers. So it's gonna be from different types. So we're gonna have A, B, A, B, A, B, B, A, or can be sometimes C or D, okay, depending on the types of the polymer. So these are the example of the copolymer where it's made up of two different monomer. So here and here are the same, but here's are different. So maybe this one is a B and this one is A. Okay, now we're going to look into the different types of polymer. So first we're going to have the natural polymer, and second we're going to have the second synthetic polymer. So for the natural polymer, it can be found naturally as it always be in our body or in our food. For example, is the protein. So the protein is an example of the polymer of amino acid, or known as the polypeptide. Next, we're going to have the carbohydrate, where the carbohydrate is the polymer for the glucose, or it's also known as the polysaccharides. Next, we're going to have our natural rubber, where we can obtain it from our latex in the rubber tree. So the natural rubber is a polymer for the polyisoprene. Okay, for the synthetic polymer, it is something that we as a chemist interested to. So synthetic here refers to their idea of man-made. Maksudnya dia adalah buatan manusia, and it can be prepared chemically in industry. Okay, so we're going to prepare that through the addition polymerization, in which we can do that in order to produce polyalkene. So there are 4 examples here. First, we're going to have the polyethylene, PE. Next, we're going to have the polyvinyl chloride, which is the PVC. And 3, we have polystyrene, which is PS. And number 4, we have the polytetrafluoroethane, which is the PTFE, or known as the Teflon. Next, we're going to have the condensation polymerisation. So, condensation polymerisation going to be further divided into 2, which is the polyamide as well as the polyester. So, for the polyamide, it basically means that the polymer going to contain a amide class of compound, and it's going to have a amide bond. So the example here is Kevlar, nylon 6 or nylon 66. Next, we're going to have the polyester. So polyester means that it's going to have the ester functional, ester class of compound, and it's going to have the ester bond. Okay, the example here going to be the Dacron and the Terylene. So now we're going to focus on the addition polymerization first, and we're going to look into the preparation of 1, 2, 3, and 4 here. Okay, so for the addition polymerization, it's basically an addition reaction in which monomers with double bonds are joined together by the covalent bond in order to form a large molecule without a loss of a small molecule. Okay, so syarat dia mesti ada double bond and it's not gonna remove any small molecule. So in this case, the C double bond C are broken and it's gonna be replaced by the carbon-carbon single bond. And the reaction will require a free radical initiator, or known as the peroxide. And this will enable the chain formation in order to form a polymer. Example as polyethylene, PE, polyvinyl chloride, as well as the polystyrene with the PTFE, which is the polytetrafluoroethane, or known as the Teflon. So now let us look into the formation of the polyethylene first. So for the polyethylene, it basically made up from the monomer of ethene. So ethene gonna have a structure of CH2 and CH2, and it gonna react together in order to produce polyethylene in the presence of peroxide, where the peroxide gonna act as a free radical initiator, in which it gonna break up the carbon-carbon double bond, and this gonna bring one electron on the right hand side and another one electron on the left hand side, and this will join one ethene molecule with another, and this gonna produce a polyethene here, and this gonna be labeled as N. To understand more about this, let us look into the upper layer here. So let's say the peroxide here will be the free radical initiator. So the double bond, we're gonna break it apart into single bond, where we're gonna bring one electron to the other side and another one electron to the other side. Similarly, this double bond of the same monomer gonna break apart, and this will also break apart. Okay, and the carbon and this carbon here gonna be forming a bond. Okay, which is this one here. Meanwhile, the double bond here gonna be a single bond, and this will create another bond with the next monomer. Okay, same goes to this side, where this bond gonna forming together, and this bond gonna link together with the next monomer. So it's gonna be linked up. Okay, and to make things simplified, you can just write it as CH2, which refers to one here, and another CH2 refer to this one here. Okay, and it is repeated by n time because it is repeated again, and repeated again, the same as what we have seen in the monomer part here. Okay, so for the polymer, we can just write it as CH2-CH2 with a letter N here. So N is depending on the number of the monomers that we have. Let's say if we have 30, then we can write it as 30 here. Okay, and the example of use of the polyethylene gonna be plastic bag or plastic bottle, as well as the film. Okay, now we're gonna look into the formation of the polyvinyl chloride, or known as the PVC. So polyvinyl chloride or vinyl chloride is known as the chloroethane. So the chloroethane gonna have the structure like this, and then with the presence of the peroxide, it gonna initiate the free radical. So the double bond gonna, because this gonna contain two electrons, right? So it's gonna bring one electron to the other side, which refers to the transfer of one electron, and this gonna transfer another electron on the left hand side, and this gonna link together in order to form a polymer, which is a polyvinyl chloride, or known as PVC. Okay, and the same thing as here, where this one gonna bring one electron here, and this gonna bring one electron here, this to this one, and this one to this one. Okay, and this also gonna break apart. So here a new bond gonna be formed, which is this bond here. Okay, and then the carbon-carbon double bond here gonna become a carbon-carbon single bond. Okay, and the same goes to the other, but in the writing of the polymer, we can just bring the repeating unit, which is the CHCl with the CH and CH here, and repeat it for a few times. So we can just put it as N here. Okay. So the use of the polyvinyl chloride can be used in pipes or as the wire insulation. Okay. Next, we're going to look into the polystyrene. So polystyrene is basically a common name for the phenylethane, where the phenylethane can be written as to be something like this. Okay. So phenylethane. Okay, so the phenylethane with the presence of peroxide, it's gonna break the one of the bond. So one electron gonna be that side, and the other electron gonna be on the left hand side. Okay, so it's gonna be repeated with its partner, and this gonna form a polystyrene as shown here. Okay, so it's gonna become CH2, and then CH2, CH2, and then instead of writing it many times, you can just put it as N. Okay, the same concept as before. Okay, but for your level, it is sufficient for you to just show it like this, and then forming a connection with another bond. Okay, so this part here shows a connection with the next monomer. Okay, and the polystyrene here can be used as a plastic container, where it is something that you use in order to tapau your food or use during the party. Okay, now we're gonna look into the Teflon. So the Teflon basically is the same meaning as the polytetrafluoroethane. So the tetrafluoroethanes meant that it is an ethene, but then it consists of 4 fluorine atoms. So with the presence of the peroxide, the carbon-carbon double bond gonna break apart in order to form carbon-carbon single bond. Okay, so here connect with this one, here connect with this one, and this one also gonna break apart. And here connect to here connect to here, and here connect to here. Okay, so as what you can see, a new bond gonna be formed, which refers to this bond. Okay, and it's gonna be repeated for how many times depending on the number of the polymer. Okay, so you can just say that the CF, 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 which is like this, can be repeated for many times, where N here can be any number greater than 30. Okay, and this refers to the connection, the similar one as what we have learned. Okay, and this is known as Teflon, and it can be used as a non-stick cooking pan as what you can see here. So it is a Teflon, or a popular brand that you use for cooking ware is Tefal. So the idea of the name or the brand of Tefal come from the Teflon. Okay, so that's all for the addition polymerization. Now we're going to look into condensation polymerization. So condensation polymerization is basically a process in which two monomers gonna form together into a larger molecule and eliminate a smaller molecule. Okay, kalau addition tadi dia mesti ada carbon-carbon double bond. But for condensation, dia tak perlu ada carbon-carbon double bond, tetapi dia hanya eliminate a smaller molecule, which is water, HCl or methanol. So example of the condensation polymerizations include the polyamide, which is the nylon 66, nylon 6, as well as the Kevlar. So it's gonna have the amide bond. Okay, so they're gonna have the amide bond. And then for the polyester, it's gonna have a ester bond. Okay, so polyamide are polymer in which individuals are joined by the amide bond. Meanwhile, the polyester, which is the blue color here, is connected by the ester bond. And the monomers must have, so kalau ada dua monomer, each monomer will have at least one functional group, or the total must have two functional group in order to act as the reactive end. Okay, now we're going to look into the explanation on how we can do the polyamide. So for condensation polymerization, in order to produce nylon 66, which is a polyamide structure, what we're going to produce is the amide bond. So the nylon 66 is produced from the reaction of the monomer of 1,6-hexane dioic acid where it gonna refers to the 6 carbon bond, which is 1, 2, 3, 4, 5, and 6, where here refer 4 carbon here refer to carbon number 2, 3, 4, 5, and at the end here refers to the carbon 6. So the carboxyl group is attached at carbon number 1 and at carbon number 6. Okay, and it's gonna react with the 1,6-hexanediamine, where the amine group is attached at carbon number 1 and also at carbon number 6, both end of the reactive group. Okay, di hujung-hujung carbon chain. So what's gonna happen here is that the OH from the carboxyl group gonna be removed, and one of the hydrogen from the amino group gonna be removed. So the H and OH gonna be removed as the byproduct of water. And what gonna be formed here is the C double bond O gonna be connected with the NH here. Okay, and here gonna produce a amide. And they are connected together, which is the two monomers gonna be connected together via an amide bond. Okay, so this is the structure. And then, as what you can see here, the OH group at the end here is also lost. Okay, same goes to the one of the hydrogen of the amino. So one of the hydrogen here gonna be lost. Okay, this is because this part here will also be reacting with the another monomer. Same goes to this part. So that is why they're gonna have the connection here. Okay, and the N here refers to the number of the monomers that are present in the molecule. Okay, so what we're going to produce is the nylon 6,6, which refers to the reaction between this 1,6-hexanoic acid and 1,6-hexadiamine. And what we're going to remove is certain number of mole of water. Okay, and the nylon 6,6 can be used in order to produce a textile or tan. Now we're going to look into the nylon 6. So it is also going to be producing an amide bond. So it is a reaction between the 6-amino hexanoic acid, where you're going to have 6 carbon, which is 1, 2, 3, 4, 5, 6, because you're going to have 5 here, right? So here. And then at carbon number 6 is going to be attached with the amino group. So it's going to be 6-amino hexanoic acid. So it's going to react with themselves, which is 6-amino hexanoic acid. So monomer yang sama akan react together. So what's going to happen here is that the same process can happen, where it's going to undergo condensation, where the OH and hydrogen bond going to be removed, and this is going to produce water. And the C double bond O and NH of the another molecule will going to be connected together. Okay, so the C double bond O, NH going to be formed. And the OH and H here going to be removed as the byproduct of water. So N here refers to the number of the monomers that are present. Okay, and the same as before, the N part here, we're also going to remove hydrogen, and the N part here, we're going to remove the OH here. Okay, so that is why it is no OH and no hydrogen here, because it is connect with another monomers. Okay, so the nylon 6,6 can be used in order to produce a net, okay, the net here, or the fishing line. All right, now we move on to the next example for the polyamide, which is the Kevlar. So Kevlar, which is the bulletproof vest, can be used in order can be produced by reacting 1,4-diaminobenzene, which is 1, 2, 3, 4, 1,4-diaminobenzene, and we're going to react that with 1,4-benzene dicarboxylic acid, 1, 2, 3, 4. So what's going to happen here is that hydrogen from the amino and the Cl from the carboxylic acid, okay, even though it is named as carboxylic acid, however, the Cl here, it basically refers to the acyl chloride. Okay, so usually we can use C double bond O OH, but sometimes the OH can be replaced with Cl in order to make the reaction more reactive. So in this case, it doesn't matter. You want to use OH or you want to use Cl, but usually we're going to use Cl because it is more reactive. Okay, and the benzene dicarboxylic acid is also known as the terephthalic acid. Okay, where it's going to be halogenated using chlorine. So what's going to happen here is that the H and Cl going to be removed, and this going to remove the HCl, and the NH and C double bond O going to be connected together. Okay, and this going to produce an amide bond here. Okay, amide bond, and as mentioned, the hydrogen, one of the hydrogen going to be removed, and the Cl here going to be removed because it's going to be connecting with another monomers at both ends. Okay, and a certain amount of HCl going to be removed. So the Kevlar here can be used in order to produce a bulletproof vest, okay, as a protection. Now we're going to look into another type of the production of the condensation polymerization, which is the polyester. So in polyester, what we're going to create is the ester bond. Okay, now we're going to look into the production of the Dacron. So for Dacron, we're going to react our 1,2-etanediol, where it refers to 1 and 2 here, and it's going to have 2 OH group, so it's going to be diol. And then we're going to react that with our dimethyl terephthalate, which is the common name. So for the naming here, you don't have to worry much because they're going to usually give the structure, and you have to predict the product. Or when the product is given, you have to give back the monomer. Okay, so in this case, what we're going to do is we're going to remove hydrogen from the alcohol and the CH3O from the carboxyl part here. Okay, and as a product of the reaction, the CH3OH going to be removed, which refers to our methanol. Okay, and our C double bond O will be connected with the oxygen of the etanediol here. Okay, so it's going to be producing something like this. C double bond O connect with the alcohol part, which is oxygen CH2, and then O here. Okay, and here refers to the ester class of compound. And as mentioned, the hydrogen going to be removed, and on this side, the OCH3 going to be removed. Okay, and that is why you don't see OCH3 here. This is because it's going to connect with the monomers at the other end. Okay, and the number n here refers to the numbers of the monomers that are present. And what we're going to release is the methanol. So for the Dacron, it can be used in order to produce fabric. Next, we're going to look into the Terylene, which is also the class of the polyester. So the Terylene can be produced when we react our 1,4-benzene dicarboxylic acid, which is 1, 2, 3, 4, and we're going to react that with our 1,2-etanediol. So what's going to happen here is that our OH and hydrogen here are going to be removed, and this going to connect the C double bond O with our etanediol part. Okay, so this is going to produce an ester. And as mentioned, the OH going to be removed the same as the hydrogen here because it's going to connecting with another monomer at both ends. Okay, and as a result, you're going to do the attachment here, and then you're going to close it with a bracket and write an N, where N here refers to the number of the monomers that are present. Okay, and you're also going to release a certain amount of H2O. And the function of Terylene, it can be used in order to do clothes or bottles. Okay, and on the last slide here is the type of polymers that we have learned as well as the usage. So you can look at it and read it by your own. Okay, I think that's all for this video. Thank you so much for watching, and this gonna remark my last video for lecture semester 2. I really hope that you enjoy and learn a lot from it. Okay, see you when I see you, and goodbye for now. Bye.